Welcome to the deep dive where we cut through the noise and get straight to the knowledge. Today we're diving into a company that's become, well, an absolute must-know in networking circles. A real market mover, Zscaler. You often hear Zscaler proxy, right? But what does it really do? So this deep dive is all about understanding why Zscaler is considered such a transformative force, a real game changer in the network and security world. Just for a quick primer, Zscaler was founded back in 2007. Mr. Jay Chaudhry and K. Kailas, headquartered right there in San Jose, California. But, to truly grasp Zscaler's innovation and why it matters to your understanding of modern networks, you first need to understand the problems, the issues it was built to solve within those older, let's call them legacy, network models. So let's unpack this a bit. Maybe you could start us off. Paint a picture of what those traditional network models actually looked like. On the ground, I mean.
Absolutely. Yeah, let's look at the typical setup, before Zscaler came along. Imagine a global company. Let's call them Network Shield, just for fun. They've got their main data center, say, in the USA, and maybe a disaster recovery site over in India. Now, this company might have, 100 branches scattered worldwide. Let's just picture maybe 5 of them, okay? Different continents. So for all their internal stuff, accessing applications, databases hosted centrally, all these branches typically connected back to that main US data center using MPLS. That was the gold standard back then, right? Secure private data transfer seemed reliable.
Okay, MPLS for the private stuff. What about just getting out to the internet?
Well, for internet access, each branch usually just had its own local ISP connection. Simple enough, right? But where it got really complicated and frankly where the costs started to spiral was backup and disaster recovery. Think about it. If that main MPLS link went down, you needed backup tunnels, IPsec tunnels specifically, and not just one. You needed tunnels from every single branch going back to both the primary data center and the disaster recovery site in India.
Oh, wow. Every single branch.
Every single one. And that meant buying dedicated VPN gateways, the hardware, plus all the licenses that go with them for every location. The overhead just exploded.
That sounds like a total nightmare, just managing all that complexity, let alone the cost. It feels like IT departments were just constantly playing whack-a-mole with devices, trying to patch security together.
Precisely. That's a good way to put it. And the pain points were, well, they were excruciating for businesses. First, just the raw cost. MPLS connectivity for every branch to 2 separate data centers, astronomically expensive, just huge recurring costs. Second, those backup IPsec tunnels we mentioned, they just piled on more costs, more VPN boxes, more licenses at every single site.
Right.
Third, the user experience. It often really suffered. If you're an employee sitting in, say, the India branch, trying to access an application hosted way over in that USA data center, you'd feel it. Real noticeable lag because of the sheer distance.
Yeah, that round-trip time kills productivity. Exactly. It wasn't just annoying, it genuinely impacted how quickly people could get work done. Then, fourth, you had this massive device sprawl. Just think about it. Every single branch needed its own stack of on-premise gear. Firewalls, URL filtering boxes, intrusion prevention systems, routers, maybe even data loss prevention tools.
A whole rack of stuff just to connect securely.
Pretty much. And finally, number 5, managing all these distributed devices required huge operational teams. You needed a dedicated 247 operations center, InfoSec teams, network security specialists, routing and switching experts, multiple levels of support like L1, L2.
So just keeping the lights on was a massive ongoing effort.
It really was a constant battle of managing boxes, configurations, updates, failures across hundreds of locations potentially.
And then, of course, the world shifted dramatically, especially post-COVID, right? Remote work suddenly became the default for so many. Users started connecting mainly via VPN software, things like Cisco AnyConnect or Palo Alto Global Protect installed right on their laptops. But often, this still meant tunneling all their traffic back through that central company data center, didn't it? Creating a whole new kind of bottleneck.
It absolutely did. That became the sort of post-COVID legacy challenge.
We also saw companies trying to move faster by adopting cloud, moving apps to AWS, Azure, GCP. Did that help? Or did it just add another layer of complexity, managing access and security across both on-prem and cloud?
That's a great question. And often, it actually introduced more complexity, believe it or not. While moving apps to the cloud was meant to improve speed, that central data center often remained the choke point. All that remote user traffic, even if they were just trying to get to Google or a cloud app, often had to funnel back through the corporate data center via the VPN, then hairpin back out to the internet or the cloud provider.
Oh, that sounds incredibly inefficient.
It was.
Yeah.
And it meant companies had to spend a fortune on really robust VPN concentrators at the data center just to handle that massive load of traffic. Plus, you always had the risk of the VPN itself going down, which could instantly cut off your entire remote workforce. So yeah, companies were really crying out for a better way, a truly modern solution to handle these persistent costs, the complexity, the performance headaches.
Okay, so that paints a very clear picture of the pain, the problems with the old way. How did Zscaler step into this mess, and what fundamentally different approach did they bring to the table?
Right, this is where Zscaler really changed the game. They introduced, I'd say, 3 foundational technologies that basically flip the old network and security models on their head. The first, and probably the most fundamental, is their zero trust approach. This is embodied in what they call the Zscaler Zero Trust Exchange. The core idea is radically different from the old castle and moat security. Instead of trusting anything just because it's inside your network, Zscaler built this global cloud-based exchange. Think of it like a secure switchboard in the cloud. All your end-user machines, your remote sites, even your traditional data centers. They all connect to this exchange. All data flows through it, and the key. There's no implicit trust given to anything, no matter where it comes from. Every connection, every user, every device has to be continually verified.
Okay, wow. That's a huge philosophical shift, isn't it? Moving from that old trust but verify inside the perimeter to never trust, always verify everywhere.
Exactly.
What are the sort of tangible benefits of that? How does that play out for a company?
Well, the benefits are really profound, and they touch everything. First, it dramatically cuts down network complexity. Massively. Instead of needing all those point-to-point MPLS links and VPN tunnels and that stack of security boxes at every site, Zscaler simplifies connectivity. Usually they deploy a lightweight virtual appliance, or sometimes a physical one, or even just a software connector at branch locations. Its main job is just to securely forward traffic to the nearest Zscaler cloud node.
So less hardware on site.
Way less. And that direct connection to the Zscaler cloud ensures high speed and, crucially, 100% security, because everything gets inspected in their cloud before it goes anywhere else. Second, user experience gets a huge boost. Applications, whether they're internal or SaaS or just web browsing, feel much faster and more responsive. Why? Because the traffic goes directly to Zscaler's nearest cloud entry point, which is likely much closer than your distant corporate data center. No more backhauling.
Makes sense. Faster path, better experience.
Third, companies gain really granular policy control. You define and manage your security policies, who can access what, under what conditions, directly within Zscaler's cloud console. That's a massive shift for IT teams. They can stop focusing so much on managing individual boxes and cables and instead focus on defining strategic, consistent security policies across the entire organization globally.
Okay, so central policy management, what else?
Fourth, threat prevention. This is huge. It's handled internally and centrally by Zscaler's cloud. We'll definitely dig into this more because it's a real game changer. And finally, you get essential compliance and reporting. Detailed logs and reports, much like you'd get from a traditional firewall or a SIEM system, gives you deep visibility into data usage, who's accessing what, bandwidth consumption across your whole global footprint. And importantly, Zscaler also guarantees seamless integration with newer technologies, like AI and machine learning, because it's already built on that kind of modern platform.
Okay, zero trust is foundational. What was the second key technology?
The second one is their cloud-native architecture. This is absolutely critical to how it all works. Zscaler operates this huge global network of data centers, I think it's over 150 now, all interconnected with really high-speed internet backbones. But here's the really crucial part. These Zscaler data centers also have high-speed, direct connections, peering arrangements with all the major cloud providers. Think AWS, Microsoft Azure, Google Cloud Platform.
Ah, so they're basically sitting right next door to where a lot of applications live now.
Exactly. This physical and network proximity ensures extremely fast and secure access for your users to applications, no matter where those apps are hosted. Could be your own data center, could be deep inside AWS or Azure. It all flows seamlessly and quickly through the Zscaler Zero Trust Exchange.
Right. Building a global fabric designed for speed and security from the get-go. Okay, and the third one, you mentioned AI-powered threat protection. That often gets highlighted as Zscaler's kind of secret sauce, doesn't it?
It really is a standout feature, yeah. It's quite amazing when you think about it. Imagine this scenario. A brand new virus, or some other emerging threat gets detected on any single system connected to the Zscaler cloud. Doesn't matter which company, doesn't matter where in the world. As soon as Zscaler identifies that threat and figures out how to block it, that threat intelligence, the signature, the behavioral pattern, the blocking rule gets instantly propagated. And when I say instantly, we're talking like within 1 to 2 minutes. That protection is shared across all 150 plus of Zscaler's data centers worldwide.
Wow, 1 to 2 minutes. Globally.
Globally, which means the fix, the protection, is automatically applied to all Zscaler customers around the world almost simultaneously. It's like this global immune system for cybersecurity that's constantly learning from threats seen anywhere and protecting everyone, everywhere, incredibly quickly. A massive collective defense mechanism.
That instant global propagation sounds incredibly powerful. But, I mean, is there any concern about false positives? Or just the sheer volume of data Zscaler has to crunch to make that happen so fast and accurately across such a huge network?
That's a very fair question, and yes, the scale is immense, but Zscaler leverages pretty sophisticated machine learning models, AI, and also behavior-based analysis, not just old-school signatures. This helps minimize false positives significantly. They're not just looking for known bad files. They're looking for weird or anomalous behavior that indicates a threat. And actually, the benefit of having such a massive diverse user base is that they see a much wider variety of threats, much earlier than any single company could. This feeds their AI models with incredibly rich data, which paradoxically helps improve accuracy over time.
So the scale becomes an advantage for detection accuracy, not just a challenge.
Exactly. And it's really a testament to the robustness of that cloud-native architecture we talked about, that they can actually process that sheer volume of threat data and push out protections so incredibly quickly.
Fascinating. So it's really interesting how those 3 core ideas, Zero Trust, Cloud Native, and AI threat protection, then translate into Zscaler's actual products that businesses buy. Let's break that down. What exactly are ZIA and ZPA in practice? How do companies actually use this stuff?
Right, absolutely. Those core technologies directly map onto Zscaler's 2 main product pillars, Zscaler Internet Access, usually called ZIA, and Zscaler Private Access, or ZPA. ZIA is all about securely connecting your users to the internet and SaaS applications. ZPA is focused on securely connecting users to your internal private applications.
Okay, ZIA for internet, ZPA for internal apps. Let's start with ZIA. What kind of features or components are included there?
Okay, so for Zscaler Internet Access, ZIA, you basically get a whole suite of cloud-delivered security services that replace that traditional stack of on-premise appliances we discussed earlier. Think of it as a comprehensive security service edge, or SA, delivered from their cloud. This includes things like a Cloud Secure Web Gateway, SWG, that's your core web filtering and security. It includes a Cloud Access Security Broker, or CASB. That's really crucial now for managing shadow IT, right? Seeing which SaaS apps employees are using, maybe without IT knowing, and applying security policies to them.
Yeah, SaaS sprawl is a huge issue.
Definitely. Then you've got Cloud Data Loss Prevention, DLP, to stop sensitive data from leaking out. There's a Zscaler Firewall Service, Cloud IPS, intrusion prevention, a Zscaler Sandbox for detonating and analyzing suspicious files safely in the cloud, AI-powered cloud browser isolation, which can render risky websites remotely to protect the end user's machine, and even digital experience monitoring, or DEM, to help troubleshoot performance issues and ensure users are having a good experience.
Wow, that's a pretty comprehensive list. Do companies have to buy all of that at once?
No, and that's a key point. It's not an all-or-nothing deal. Companies can pick and choose which of these ZIA modules or services they want in a license based on their specific security needs, their risk profile, and of course, their budget. It's quite flexible.
Okay, that makes sense. Modularity is good. So what about ZPA then? How does Zscaler handle secure access to internal applications without using those clunky old VPNs?
Right, so for Zscaler Private Access, ZPA, the goal is secure, direct access to internal apps, whether they're in your data center or in a private cloud environment like AWS or Azure. There are primarily 2 main components that work together with their global Zscaler cloud. First, there's the Zscaler Client Connector. This is lightweight software, an agent that gets installed on the user's laptop or mobile device. This connector establishes a secure encrypted tunnel from the user's device directly to the Zscaler Zero Trust Exchange. It basically handles authenticating the user and connecting them securely into the Zscaler cloud, completely bypassing the need for traditional VPN clients and all that traffic backhauling.
Okay, so the user connects to Zscaler first. How does the traffic get to the actual application then?
Good question. That's where the second component comes in. app connectors. These are small, lightweight virtual machines or software processes that you deploy inside your private network. So within your data centers or your VPCs in the cloud, right next to where your applications actually live. Now, instead of you having to open inbound firewall holes or set up complex VPN tunnels to your network, these app connectors do something clever. They create an outbound-only connection from your network up to the Zscaler Zero Trust Exchange.
Ah, outbound only. So the applications themselves are never directly exposed to the internet.
Exactly. That's a huge security benefit. The app connector basically acts as a secure rendezvous point in the Zscaler cloud. When an authenticated user, via the client connector, tries to access a specific internal app, Zscaler stitches together that connection within its cloud, connecting the user's session to the appropriate app connector, which then forwards the traffic directly to the application server. It ensures a secure, fast, direct path to the application, bypassing all those traditional VPN bottlenecks that caused slowness and complexity.
And this all leverages that global cloud network you mentioned earlier.
Precisely. It all rides on that global Zscaler cloud with its 150-plus data centers and those high-speed links to the major cloud providers. So you get secure, fast access, whether your app is running in your own building or somewhere in Azure, for instance.
That sounds like an incredibly compelling story, a really elegant solution to those legacy problems. But, with such a fundamental shift in how networks and security are designed, what are some of the common misconceptions companies might have about Zscaler? Or maybe what are the biggest hurdles they face when they actually try to adopt it?
Yeah, great question. There are definitely a few. One common misconception is thinking it's just, a cloud proxy or simply a VPN replacement. And while it certainly replaces those functions, it's much more fundamental. It's really a complete architectural overhaul, a strategic shift towards a secure service edge or SASE model.
So thinking too tactically instead of strategically.
Exactly. And probably the biggest hurdle for many companies isn't actually the technology itself. The tech is pretty mature and robust now. It's often the organizational change required. It really forces IT and security teams to rethink their traditional on-premise focused ways of working. They have to embrace a cloud-first, zero-trust mindset. Which policies move to the cloud? How do operations change when you don't manage the physical boxes anymore?
Right, impacts workflows, skill sets, team structures.
For sure. It's a strategic investment that generally pays huge dividends in security, user experience, and cost savings down the line, but it does mean changing how security operations are structured and managed day to day. It's as much about people and process transformation as it is about the tech.
That makes perfect sense. Shifting paradigms is always more than just swapping out technology. So when you pull it all together then, Zscaler's core value proposition seems pretty clear. It aims to significantly reduce costs, definitely streamline operations by removing all that distributed hardware, and provide a faster, much more secure connectivity experience. And that's for any user, right? On any device, laptops, mobiles, accessing any application, no matter where it lives.
That's the goal, yeah.
It really is complete rethinking of the network and security paradigm, built for the cloud and remote work era. We really encourage you, the listener, to think about the strategic implications of this shift. How might this model impact how you think about designing and securing networks?
And maybe a final thought to leave folks with. If Zscaler's AI-powered threat protection can instantly share virus data and protective solutions globally, like that collective immune system we talked about, how might that kind of collective defense model change the future of cybersecurity, maybe even beyond just network infrastructure? What new possibilities, or perhaps even new challenges, could emerge for us as individual users as this kind of instant global threat sharing becomes more widespread? Something to ponder.